2.4 solving equations. These are proportions. We're still seeing equations, the equal sign. We still need to solve, but now it's with proportions, which are a fraction equals another fraction. So step one, we are going to do the cross multiplying, and it kind of looks like a butterfly. So you're going to see something like, you're going to go across the equal sign and multiply one numerator with the other fraction's denominator. So after you do that, then you will simplify each side of the new equation, which is like terms and distributing. And then lastly, you solve or isolate, let's say isolate, get the variable by itself. Isolating the variable means you're solving for it. So all right, let's get started. I'm going to take 4 in the numerator times 6. And that's going to equal 3 times x. So that's step 1, cross multiplying. Step 2 is simplify each side. So 4 times 6, 24. 3 times x is just 3x. Nothing else to simplify there. Lastly, third step is to isolate the variables. So the variable is here with the x. We need to get rid of it. We move the 3. 3 is attached to the x by a multiplication. Opposite operation of multiplication is division. And we get 8. 24 divided by 3 is 8, and that equals x, which you can switch that around. So 8 equals x equals 8. All right, looking at number 2. Let's do the exact same thing. So we have 2 times n plus 5. Well, n plus 5 is 2 terms. So we need to show that we are going to multiply the 2 by both terms. And what you're showing is you put an n plus 5 in parentheses, which then in turn you're going to be doing distributive property. And then 10 times 4 is your next side of the right side of the equal sign. Doesn't matter if it's right or left. After this, then we do distributive property. So, all right, little music here. We do distributive property. 2 times n is 2n plus, or 2 times a positive 5 is a positive 10, so plus 10. 10 times 4 is 40. All right, both sides as equal sign are simplified. We now need to see if there's any like terms. There we do actually have like terms on opposite sides of the equal sign, so 10 and 40. So we could do that. Otherwise, you look at the n, and from the n we have a multiplication times 2, and we have adding 10. Reverse order of operations would mean you have to take care of the addition first. That's the last thing in order of operations is addition and subtraction. So bringing down the 2n equals 40 minus 10 is 30. We divide by 2, and n is going to equal 15. Keep moving on. Number 3. We have top left numerator times bottom right denominator. So we have y plus 3 times 5. You can write the times 5 on the right. I'm going to actually write it on the left. That's the commutative property of multiplication state. So you can multiply in any order you want as long as you have multiplication. You have 2 times y. Usually, typically, we write the variable on the left, so I'm going to write 2 times y just like that. Then we're going to do, and if you ever have distributing, that'll always be your next step. 5y times 5 times 3 is 15. And that's going to equal 2 times y, which is just 2y. Let's see if we have any like terms. We sure do. We have the 5y and 2y. Those are our like terms, so that's where our concentration is next. And with those like terms, if I move the 2y to the 5y, so I subtract 2y, then it's going to be nothing, no terms left except for 0 on the right side. We don't want that. You want your variable terms on one side of the equal sign and the constant terms on the other. So I am actually going to subtract. This is a positive 5y, so I'm going to subtract 5y. I don't typically like to have negative variables, but in this case, there's no choice. Positive 15 comes down. You have 2y's, and I subtract 5y's. That means I'm going to be negative 3y. And then lastly, we have 15 equals negative 3y. And that's a multiplication times y. We're going to divide by negative 3. Y is going to equal 15 divided by negative 3 is negative 5. Next, we have 2k minus 3 times 5. So again, I'm going to put the 5 on the left. 2k minus 3 equals, another binomial times a monomial. So 3 times k plus 9, 2 terms that are binomial. Looks like we have double distribution that we have to do. So it's 5 times 2k, 10k. 5 times a negative 3 is a negative 15, so I write minus 15. 3 times k is 3k. 3 times a positive 9 is a positive 27, so I write plus 27. No like terms on the same side of the equal sign, but on opposite sides we sure have like terms. We have 3k and 10k. We'll get those together, and then we'll have the negative 15 and 27. We're going to put those on opposite sides of the equal sign from each other. Typically, I'll try to make the k's positive. It doesn't really matter. 3k, this is a positive 3k, so we're going to have to, when we're going across the equal sign, we're moving it to the other side of the equal sign. We always got to do the opposite operation. So subtract 3k. If we have 10k's and we subtract 3k's, we have 7k's left. Minus 15, 3k minus 3k is 0. Positive 27 comes down. Now we have the minus 15. I'm going to move that constant term to the right side of the equal sign. 7k, negative 15 plus 15, simplify. 27 plus 15 is 42. Divide by 7, and we get k is going to equal 6. All right, that is it for your notes. Moving on to the U-tries. All right, here we have 10 plus, or x plus 10 times 3 equals 8 times x. Distribute. And then we need to get our like terms together, 3x and 8x. So 3x is positive. I'm going to subtract 3x to move my x's to the right side of the equal sign. So then this 30, this constant, will be on by itself on the left side of the equal sign. And then we have 8x's minus 3x's, and we have 5x's left. Divide by 5, that's the opposite of multiplication. X is going to equal 6. Number 6. P plus 2 times 6. Typically, I write the single term monomial on the left. So 6 times p plus 2. 3 times p plus 7. Distribute. 6 times p is 6p. 6 times a positive 2 is a positive 12, so I write plus 12. 3 times p is 3p. 3 times a positive 7 is positive 21, so I write plus 21. Then we're looking at like terms. We have 3p and 6p. If I subtract 3p from 6p, that's still a positive 3p, so I like that positives. Positive 21 plus 21, positive 21 is coming down. We're going to subtract 12 to move the constant term to the opposite side of the variable term. 21 minus 12 is 9. Divide by 3, divide by 3. P is going to equal 3. Number 7. We have w minus 2 times 6. 6 times w minus 2. W times 3 is 3w. Distribute. 6w minus 12 equals 3w. At this point, move in terms. If I'm going to move the 6w, so this is minus 6w, to the right side of the equal sign. It is negative, but Then we're getting our W, or variable terms, on the opposite side of the constant term. The constant is negative 12. That's just a number. If we have 3 W's and we subtract 6 W's, we're going to have be a negative, so 3 minus 6 is negative 3. Negative 3W means negative 3 times W, so we divide by negative 3 to get that W by itself. Last step. And we get W is by itself equals a negative divided by a negative is a positive. 12 divided by 3 is 4. Number 8. N minus 4 times 9. 6 times n plus 7. Or n minus 7, sorry. N minus 7. Do some distributing. 9 times n is 9n. 9 times a negative 4 is negative 36, so I write minus 36. 6 times n is 6n. 6 times a negative 7 is a negative 42, so I write minus 42. Let's get our like terms together. We have 9n and 6n. I'm going to subtract 6n. You could subtract 9n. Nothing wrong with that. If I have 9 n's and I subtract 6 n's, I have 3 n's left. The negative 36 and negative 42 are like terms. I'm going to move. Now we only have one term, one variable left in the whole term, in the whole problem. So you always are just going to, at that point, move everything away from it. So we have subtract 36, so we add 36. We'll come up here. We have 3n left over equals, that's a negative 6. And then we divide by 3, negative divided by positive is a negative. 6 divided by 3 is 2. So negative 2. All right, number 9, we're getting there. 3 times a plus 1 equals 2 times a minus 3. That's distributing 3a plus 3 times 1, 2 times a, 2 times negative 3 is negative 6. Let's get our like terms together. I'm going to subtract 2a. You could subtract 3a, but 3a minus 2a is 1a, or just a, so that's good. It's a positive. I like positives. Minus 6 becomes a negative 6. We're going to subtract 3 from the negative 6. Those are our like terms. We have 1a, which is just a. 1 times a is a. Negative 6 minus 3 is negative 9. So the a is going to equal negative 9. Sweet. Number 10. 25 times 3. Oh, we haven't had one of these in a while. F plus 2 times 5. 5 times f plus 2. Simplify the left side. 25 times 3 is 75. 5 times f is 5f. Plus 5 times positive 2 is, I should write, it's a positive 10, so plus 10. Subtract 10, subtract 10. 75 minus 10 is 65. 5f, divide by 5. And we're going to get f equaling 65 divided by 5 is 13. I think that is it. Yes, that is it. So if you have any questions,